So pi is like your 3.1415. It's a string of number, right? Euler is the same thing. So if you want to know what that string of number is, go to your calculator and find the letter E. Where is my letter? Yeah, you know the times 10 to the power of x at the bottom. Do you see the red letter there? You call out the function by pressing alpha. Then you press the Euler number. Then press equal. You will see 2.718281828 and so on. Yes.
What about the one where you press shift and then it's next to the LN?
That one allows you to change the power for Euler. That means the E, right? You can raise it to square. You can cube it.
No, because when I was like following the video and then I tried pressing this Euler, it didn't work. It was like not.
No, so if it's this E, right? The one that follows the long button, if you press that function, you need to give it a power. So if you want that number, you power 1.
No, I did put the power, but then it was like.
So see, if you call out the function, right? 1. And this is the same thing as this. You can go square, you can go cube. Okay? So anyway, these laws, it will be applicable in this chapter. So if you just look at this one is just recap of your indices. So I will not go through that. This is exactly EMAF. We put it there to help you recap the laws, but it's not the AMAF component. So this is the recap part. Okay, this is the thing. The simpler ones will require you to simplify your answer. So instead of focusing on numbers, it is the X that is more essential here. So I just go through one example here. So 81 to the power of x plus 1. And then 9 to the power of 2x. All this number has the simplest base number what? 3. So actually 81 is 3 to the power of 4. Okay, you can change that into 3 to the power of 4. And then here 9 is 3 squared. So to simplify it, I eventually get the power to become, this one is 4x, right? And then there's a 1 here that you add. So 4x plus 1. Okay? So you can see this. Then at the denominator, they also have base 3. So what you can see is the base here you can also change. 3x minus 2 times 3 square x plus 1. So this one you can multiply together. So I add up the power x minus 2 plus 2x plus 2. Okay, so all these still EMAF laws. There's nothing special here. Okay, so all the way you go and simplify this thing at the bottom is 3x at the bottom, and then at the top I get this. So how do I eventually get here? How do I eventually get to that point there? I don't have a denominator as the simplified form, right? So that means I must be able to simplify this away. So if you want, you can extract the common factor 3 to the power of 3x on top, so that you can cancel it out. So if I take out 3x, I'm only left with 1x and then the plus 4 there. Okay, don't believe you add back the power, it should give you the same thing. So same thing here, I take out the 3x, so I'm left with x plus 1. Okay, so the 3x at the bottom will cancel out. So it is still your indices law at EMAF, but just that they want you to play around with it a bit more. It's higher level. 1 to the power of? Which one? This part? Last step. This one. I take it out means, because remember when we multiply, we add the power. So this one, when 3 to the power of 3x times 3 to the power of x plus 1, we are actually adding the power. Yeah, so it's x plus 1 left lah. Correct, right? 4, did I miss out anything? Yeah, correct. So this one can cancel out already, gone. No more. But how do I get from here to here? This is a product, right? It means I must extract some common factor between the two of them. So what is the common thing between the two of them? 3 to the power of x. So I take out the 3 to the power of x. This one left this. Okay, I take out the 3 to the power of x. This one left this. Okay, so in the end, here, it will end up as being another number. So 3 to the power 4 is 81 plus 3, so 84. And then I have a 3x. So can you see that it's exactly this form? My b is 3, my a is 84. So it is still indices law, but just that they challenge you to factorize, they challenge you to play around with the rules a bit deeper. Okay, so the 5.1 is more or less this kind, but the difficult one is the substitution one. So let's just quickly, I've got 4 minutes. Can I? Solving is nothing new, all these are. So the only new part for A Math is the solving by substitution. And they are not always so kind to tell you what to substitute. You are supposed to make your own decision. So this is the guided ones, but the real ones will be like that. Then they expect you to solve on your own. So what we do is you want to make 2 to the power of x as y. So this one can change to y already, no problem.
Can I do a eating?
Yes, can. Okay, but this is the one that you need to change a little bit. So 4 is 2 squared. Right? So it's the same thing as 2 to the power of 2x. And it's also the same thing as me writing it as 2x to the power squared. Okay, whether I 2 times x or x times 2 is the same thing. So I'm just rearranging it so that I can do substitution easily, because this one is y. So actually this one I can change to y squared. So when you change it to this, it's just quadratic formula. You can factorize it easily. Okay, so this solving shouldn't be difficult for you because it is just what you do all the time in Sec 2 all the way to Sec 3. Okay, so when you solve it, you get this. So this is the only new thing in 5.1 that is A Math. Like A Math, you need to use substitution to solve the indices question. So once you reach here, you are not done yet because your ultimate goal is to solve for x. So you put in 2x here, put back 2x here. Then you realize that actually in order to solve for this, 2 is 2 to the power of 1. So therefore x must be 1. Okay, this one is 2 cubed. So therefore x must be 3. So this is by substitution. So the only new thing here for 5.1 is substitution. Okay, so this one how to change? Remember 4 is 2 squared. So you end up having this. This one no problem, change to y. So what you need to do here is that this one here, you need to do a little bit of splitting. Okay, I will teach you how to do splitting so that everything becomes easier. So whenever you have this, you can split this into 2. Your 2x times, oops. Okay, in A Math, we like to use the big dot to represent times because it's easier to write. Then 2 squared. When you times, it's the same as add. So you can always split back into the multiplication. So this part very easy for you to change. This is y squared. Okay, this is just 4. So once you see that, you can go and factorize this equation. So 5.1 is just like that. I let y be 5 of x. So this one is y. This one is 1 over y. So I don't like fractions. I multiply everything by y. So this will be y squared plus 1 minus 2y equals to 0. So this part here, I just Correct or not? Plus 1 minus 2. Yeah, correct. So I factorize become like that. So when I solve it, it's a repeated root. So y is equals to 1. But I'm not solving for y. I need to put back my 5 to the power of x. So how can anything be 1?
Power 0.
If the power is 0. So I can also change this to 5, 0. So x is just 0. Okay, these are the ones at 5.1. All your numbers are nice. It's either you can compare and solve, or there's no real roots, or it's 0. But when we go into 5.2, you will start seeing answers that has decimal points. Okay, 5.1, the answers are all very nice. Okay, because you haven't learned log or ln. Once you learn log and ln, your answer can be a complex number. So what I'm saying is you will see questions that requires you to do substitution. But it is just like indices. It is like your EMath extension. Okay. So you see this whole chunk, right? It's all indices. Yeah, the exam type is this kind. Okay? But what they actually really like you to always do is the splitting. So maybe let me just go through this one. This one is an O-level question. Look like very complicated, but they say, can you show that this number is divisible by 43? So actually, they want you to be able to find out that this simplifies to a number 43 times something. So if you can show me it's 43 times something, then it is divisible. So this one, I want you all to think. What do you think I should do here? So the idea is actually split them up. Remember just now I said this one can split like that. So this one also split like that. And then now everything has a 6 to the power of n that I can take out. Okay, so I'm going to take out the 6 to the power of n. So if I take this out, left 1. I take this out, left 6. Take this out, left 36. So can you see that this one is 43? So if I can show that this is 43 times 6 to the power of n, this number is always divisible by 43 because it has a factor 43, or it is a multiple of 43. Yes. You can tell me, since it has a factor 43, it is always divisible by 43. Or you can tell me, since it is a multiple of 43, okay, it is always divisible by 43. So this is also what EMath likes to test as a difficult question. Okay, but AMath will test this as a normal question. So just make sure that you know how to split and you know how to substitute. Okay, because 5.1 is all about that. So if you just want to test your understanding for 5.1, go and try the PMP. I don't say try like do on the foolscap paper properly, neatly. Yes, can. Okay, so if you browse through 5.1 today, right, you will realize that the PMP question, most of it you must be able to do because it's all based on EMath concept. The only new thing is substitution and the splitting, because EMath rarely requires you to split. Okay, but AMath wants you to split so that you can substitute. Okay, so that is the only new part for 5.1. Okay, 5.2 is graph. There's just 2 graphs you will see. Actually my time is out. Okay, I talk too much. Can I just draw one graph? Later our chem teacher will scold me. Miss Lee ha. Okay, anyway, log graph looks like that. Okay? It's either like that or like that only. Okay? So actually, you see your log.
So it doesn't intersect y and c.
Okay, let's say this is your log graph, right? Okay, or rather, let me use x and 1. Okay, this is your log graph, right? The A value determines the shape. This A cannot be negative. It also cannot be 1. So when your A value is between 0 and 1, the shape looks like that. Okay, when your A value is between 0 and 1, the shape looks like that. But when your A value is more than 1, then your shape value looks like that. Only these two. And then where this thing is, it depends on what this expression is. Okay? So this one we'll talk about it next lesson. But I'm just telling you, only got two shapes. So the entire graph, past history, they never test the sketching for logarithm at all before. Okay? For the last 10 years or 10-year series, you cannot find one question where they ask you to draw log. Okay? But you need to know the shape lah. Yes. Exponential is like that. Your exponential is like that. Remember, your exponential is like that. So when your power becomes negative, then it flips the other side. So all these are the different shapes that EMATH learns this, but EMATH don't learn this. So your extra 2 is log 4. Oh, so 35, just nice. Then you all say 30. Okay, so actually all the shapes that you have learned, these are the 2 additional ones. So other people got 12, you got 14. But if you throw out your sine, cosine, tangent graph, then you got 17. Then you throw out your circle, then you got 18. Okay, so that is your power. And 10, okay, can. So when you look at this, you know you need to change everything to base 5 first. Okay, you need to change everything to base 5. So once we are there, you use indices law to make this 4y. So bracket can change to a times. So if we simplify this one, a multiply is an addition. So we add up the power. So your indices laws must be very good so that this chapter won't trap you. Okay, so with that, we can compare the powers and drop the base. So this is your first equation that you form, equation 1. So this question is a simultaneous equation. You have to form 2 to solve for x and y.
I don't get how 27 becomes negative.
27 is base 3.
Yeah, but how does the index become negative? Oh, because you combine with the negative.
Yes. So this one is 3, 3.
Okay, got it.
Okay, 27 is 3 base 3. And then we have a 3 negative y. This 1/3, no, this is 1/9. So it's 1 3 square. Okay, so I'm going to combine this as 3 to the power of 3x. Bracket change to times. Okay, and then I'm going to shift this up and change it to negative power. So all these are your indices laws. Okay, so I add the 2 powers up. So now I drop the base.
And then after
Harini,
that,
you have the notes? Never bring.
After that, it's just simultaneous. Right?
Yes. So after that, you get your 2 equations. You can form simultaneous and solve. That's all. So this one I don't need to show, right? You should be very good at it already. Yes. Okay, the solving part, no problem. Okay, let me show 10 also. Can, right? I think should be okay. 10 is like the 8 I show.
I can't find my...
Okay, so question 10, when you see this kind of question, they say exactly divisible by 11. They want you to extract common factor 11 out. So if you can express it as 11 times something, then you can show already. So first thing first, this one is 2 to the power of n. So I have 59 of them. Okay, this one I'm going to split it into 2 parts. 2n and 25. Because multiply is adding power. Okay, so I'm splitting this up. Okay, and then this one I also split. So 2n times 2 cube. So you can split it. Yes. Once you can see this, you can see 2 to the power of n is a common factor that you might want to take out. So I take out the common factor 2 to the power of n. I'm left with 59 here. 2 to the power of 5 is 32. And then 2 to the power of 3 is 8. So add it all up, you get 99. So 99, you can take out 11 easily. Right? So you can express your answer like that and then tell me, since 11 is a factor of this entire expression, okay, therefore it is divisible by 11. Or you can tell me, since this whole thing is a multiple of 11, it is divisible by 11. So it's standard. Whether they say divisible or multiple, it's the same thing. Yes? 3. Yeah.
So like if you just write the statement without any words.
Cannot. You must show. You must show me that really you could take the 11 out. Yeah. Okay, so the splitting is the essential step. Taking out the 11 and then of course the concluding statement.
Can I do anything?
Okay, so remember for 5.1, the important thing is substitution and splitting. So this action you see here, splitting this from this, splitting this from this, it's the key skills to have for 5.1. Okay, so I already did, out of the 13 questions here, I did 3. So only 10 questions here, homework.
The ones you did was
8. Yeah.
For splitting, it's usually the same.
Yes. Correct.
Would there be any instance?
5. Which?
No.
What's the
Possible. So like this, you split it into 2x and 3x. Because this is the same as 2 times 3x.
What if plus 6 and 6?
Plus 6 and plus 2.
Like for your highlighter, change.
This one change to plus 6. Then this one will be 6, oh? Okay, Yes. Yeah. Okay, so this is all for 5.1. 5.1, we talk about the importance of substitution and splitting. That's all. Okay, the rest is all your indices law. So we go into 5.2. So 5.2. Okay, so I told you the other day that exponential graph we learned before already. Exponential graph, remember, we learned that y equals to ax looks like this. Okay, that time we talk about it. Okay, when x is 0, this one always pass through 1. Oops. Okay, so this one you learn in E-math. It's nothing new. And then of course, if your power is negative x, and then your graph is the other direction, but it also pass through 1 at x equals to 0. So these two graphs is not new. It's the same thing. So that means this number here can be any number, right? So even if I switch it to be exponential, I switch this into exponential, it should also give me the same shape. Because this E is just a 2.718 something, right? It's just a number, a constant. And A can take any constant number. So if this is E, it's still this shape. If this is E, this is also this shape. So the shape is the same. So it's not a new graph. The only new graph is ln. Okay, the only new graph is ln. So this page, we have talked about it already. It's about the graph. So not much. So if they ask you to sketch, it's also the same thing. This one is like this. So that the video already show you how to sketch. So I'm not going to go through in detail, but it's just like that, right? And then pass through 1. So this is your x, this is your y. Okay, so even if it's ex, it's the same thing. Just change that equation to ex. Everything else is the same. Okay, even if it's pi x, also same thing. Because that number there is greater than 1. So this number here, as long as it's not a fraction, it will always be that shape, no matter what number I change. Okay, but what if I have a 6 here? The only thing that changed is one value. What is it? The y-intercept. So this one changed to 6. Oops. Okay? So remember, when there's a number in front, a constant number in front, it will only affect my y-intercept value. The shape is the same. Okay? Then, when it's negative power, same thing. Instead of that side, we go to the other side. Okay? But the y-intercept value is 2. But it's still the same shape. So y equals to 2e minus x. So the shape is all consistently the same. Even if it's this, it's also this shape. Okay? So these two, E and F shares the same type of graph. E and F shares the same type of graph. And then, yeah, A, B, C, D, all the same type of graph. Okay, just that the y-intercept value is different. Okay, what about the last one? Is it the green type or the blue type? The green type, right? Because it's positive. This number here is more than 1. So it's going to be this shape, but pass through the y-intercept at 3. So the shape is either this or that. That's all. Okay? But why I say the number here must be more than 1 is because if it's not more than 1, what happened? So for example, if I say my equation is y equals to 0.5x. It's not more than 1, right? It's not between 0 and 1. Then what happened? This is half. Then this will become this. And then this will become this. Then the power of x becomes negative. So you are drawing the blue graph instead. So if the number here is not greater than 1, you will end up having a fraction. And when you bring it up, the power of x is negative. So your graph is this shape.
What if it's 1?
What do you mean? 1, no graph already. It's just a horizontal line. If it's just exactly 1, 1 to the power of x is still 1. So the line you draw is just a horizontal line at 1. So it's either greater than 1 or less than 1. Okay? These two types of graph only for exponential. Okay, nothing much. Okay, this one is just, what do we call that? Word problems for exponential equation. So I was told to go through 3, is it? Is it this one? 3, is it? Okay, so if you watch the video, right, I will have gone through all the examples already. So maybe I go through the first one and the last one. So example, exponential function. In nature, right, there are a few things that undergoes exponential growth or exponential decay. So somehow the magic in this natural environment is, no matter how they grow, right, they all approach the number e. The growth rate approach the number e. So that's why this Euler number is very interesting. When time approaches infinity long enough, the growth rate approaches e. Okay, this growth rate, 2.718 something. Okay, so same for population, same for your bacterial culture growth, same for your one other radioactive. Okay, so all the bio students, you will see all these things you put in the culture this, and then it will grow in that same rate. Okay, so when we look at this, they always say, okay, this growth rate follows this exponential function. So they tell you that this is the growth rate of the population of fruit flies. It's always exponential growth. Okay, so after X days, this is what the equation is. So they say, can you find the number of fruit flies at the beginning of the experiment? Beginning means 0 days. Correct. So you just need to know what to sub in when they give you certain terms. Sometimes they use the word initial. Okay, it means it hasn't started. So you just sub in 50, 2 to the power of 0, and then you know it's just 50. You started off with 50 fruit flies. Okay, start off with 50. And then they say, oh, in 3.5 days later, then just sub in 3.5 lah. Okay, then you give me the population of fruit flies. That's all. It's all about interpreting the number to sub in. Okay, 565.685.
What's the hardest version for this graph?
Sorry?
The hardest version.
It's just the terms they use. Like becomes double of its population, half its population. You must know how to interpret. Okay, so 3SF566.
But they cannot be more. The flies cannot increase, right? They live from it.
Yeah, but they never say the number of whole.
No, but isn't it like generally? It's a general line, like if it's like a living.
Find the population. So you all will argue that we should round down, huh?
Isn't it just the approximate number of flies?
Yeah, because it's not actual number. Okay, this one is actual number, right?
Wait, but this one should
Yes.
be approximated to the nearest one because it's just the approximate amount of fruit flies.
Yeah, but the argument that they are saying is the 0.6 is not good enough to be one fly. Okay, every year, to be honest with you, every year we will have argument about the marking scheme, about rounding up, rounding down, rounding what. But during your exam, we will always specify nearest whole number to the nearest whole. We will be very specific on what you need to do. Okay, but when in doubt, usually we round off to 3SF. But I agree that yes, it could be 565 also. Okay, so in this case, if we are talking about actual fruit flies, then at most we can have 565. Okay, but if we are rounding off to a certain level of the accuracy, 566 is the correct one also.
So it's both accepted.
So you'll accept both. Okay, but your exam will be very specific, okay? Okay, next one. This one we're not going through already, right? This one you can watch. We don't go through every single
They
thing.
give us the E, right? Do we have to use calculator?
Yes, use the calculator E. Okay, so this one, you see value of A, right? They say at the beginning, there's 250. So when T is 0, they say Y is 250. Then you can go and solve for A lah. Okay, so all this is just substituting.
Why is it not 0 for the power?
Because at the beginning, I haven't even start from 1 day. It's 0 days. So beginning means 0 days. 0 days. Okay? So this one is after 5 years, so T equals to 5. After 1 decade, decade is how many years? So just sub in. So it's just substitution, but you must understand what the question is asking. So this one you just follow through. So I don't want to spend time going through the how to press calculator. That one you should know. You all know how to press the exponential, right? It's at the bottom of your calculator here. The red color E. You can press alpha, followed by the button times 10 to the power of x at the bottom. You will see E there. Okay, when you see E, you can raise it to power negative. Do you all need me to show or not?
No need.
This one. Let's just practice some. Okay, so V is the value of a house. Okay, this is called V node. Node. But it just means initial. Initial V. V at time 0. Okay, so there's a lot of terms to represent this V naught. Okay, but it is initial value of V. It's just a constant value. Okay, they say, you see, it's the original value of the house. So don't be scared by the subscript 0, it's just a symbol. Okay, then it says T is the time in years since it's built and K is a constant. So find the value of K if after 10 years. So 10 years means when T is 10, they say the value of the house doubled. So if this is the initial value, if this is the initial, what is the new value now? 2V. 2V naught. It's 2 times the initial value. So this means it is doubled. The value of the house now has doubled. So when they say the house doubled, means now my value of V I sub in as 2V naught. So I'm going to substitute this as 2V naught K times T. So you realize that I can cancel out this. Cancel off already. Okay, and then I have 2 E10K. Okay, the issue now is at 5.2, you haven't learned how to solve exponential equation. So I'm going to tell you now what you need to do to solve for the power is to ln both sides. So when you see exponential, to bring this power down, you need to take a ln. Okay, but what you do to the right hand side, you must do the same thing to the left. So I need to ln the 2 as well. Okay, so the law says that if you ln the expression, you can bring this power down to the front as a constant. So this is the only difficult part that you have not learned. Okay, so later in 5.3, I will explore this deeper, how to bring down the power, how to ln the expression. For now, let's take it to be that. So I can't solve from here, right? I'm not able to make both of them the same base. They are already different. So when they are of the different base, when it's exponential, I ln both sides. And when I ln both sides, I'm allowed to take the power down as a constant to multiply. Okay, so I bring it down. So now my 10K is here. You go and press calculator. What is ln E? 1. You go and press ln E. Where is your ln? This thing here is just 1. No more already. Okay, but ln 2 is a number. So you keep it first. So to solve for K, is ln 2 divided by 10. Is it 5? No, we are not nice number. Okay, when you ln both sides, you can take the power down as a constant. So this thing is just 1, not affecting anything. So to solve for T, you just ln 3 divided by this whole thing. Okay? So because T is in years, 3SF is good enough. No need to be whole number. Okay, so just take note that this chapter is just a lot of laws and rules. So you get 15.8 years. Okay, problem sum is just what you substitute. The solving part is the new thing here. The solving part. Okay, taking ln on both sides.
You see for this, right? You know, since A is 2 to the power 3 equals A, right? But then this is 3 to the power 5. How it's not? is 3 to the power of 5, isn't that like?
Yeah, so got typo then. That should be 7, I think. 3 to the power of 7 or 7 to the power of 3. Okay, wait, where's... Oh, no, wrong. Got something wrong. Okay, this question got error. Okay, but good observation. Okay, can So problem sum 5.2. The types of graphs. How to solve by taking ln on both sides. This is the only new feature. Okay, this part. Can? The details of all the other parts, if you want to try on your own, you can. But otherwise, when you watch the video, I went through all. Okay, so take that time to go and watch it. No notes. The rules not at all Okay, then I go through the rules. Okay, done? Okay, then let's go through. Okay, logarithm has some laws and ln has some laws, but they are mostly the same. Okay, but just take note of the few that I mentioned later. Okay, log and ln is very fun. I love it because the law is very interesting. All these are like a must get. You just take the marks, free one. Take. Don't be careless, can already.
So the formula for polynomial dot a minus b cubed. A minus
A cube minus b cube, not a minus b cube. So a minus b
a minus b, and that is a square
plus ab
plus ab
plus b square.
that is opposite.
Yes. The logarithm laws. I'm not done. Can done? Can Okay, so let's talk about the laws. First thing first, these two are interchangeable. That means they are just different forms of each other. So for example, y is equal to a to the power of x. This is your exponential equation. But just now we learned that in order to bring the power down, we can take ln on both sides, or we can take log on both sides. So I'm going to do that the same way. So if I take log on the both sides, log comes with a base number. So this one is log base a. Okay? Why I need it to be log base a? Because these two must always be the same. So I apply log base a to both sides. Okay? Yeah. Okay, and then this is my y.
Cannot remember the
Okay? So don't worry, later the rules will come naturally to you. So when these are the same, it means I can bring this power down. Okay, it means I can bring this power down. So this thing is equals to 1. When the base number of the log and the number you apply inside is the same, it becomes 1. So this is property number 1. This is the first property you need to know. Okay? Then, this thing will stay. So what they are saying is, this is the other form. This is the logarithmic form of the equation, and this is the index form. So there are two equivalent forms of each other. We apply this form when we want to solve. So this will help me solve it. Okay, this will help me solve x equals to this. Okay, this one help me to solve. But this is the original one that we are given, so that the graph is easy to plot. Okay, so these are the two different forms. Okay, but is there an easy way out to convert between this form? Yes. Okay, I will explain to you in a bit. Okay, but some things for you to take note is this number inside of the log function must always be positive. Cannot have negative number, otherwise it will give you math error. Because a log function cannot log a negative number. Okay, that's rule number 1. Next, the base number must be positive. and not equals to 1. So this base number you see here must always be positive and not equals to 1. So if you look at all the numbers here, all the expression they write here, there are some that are invalid. So which are the ones that are invalid? Anything that has negative inside is out. So these two out, right? Then you look at all the rest. B is out because this one cannot be negative, so this one out. This one cannot be 1, so also out. This one must be positive, so this one is also out. So the only two valid ones are these two. Okay? So this is just telling you which one is an invalid fraction. Okay, why is this important? It's because sometimes after you solve, you get two solutions, right? You need to sub back to check whether you need to reject or not. And if it's invalid, you must reject. Yes?
The log base can be like high or something.
Can. As long as it is positive and not equals to 1. Okay, so now, if they want you to convert to index form, okay, if they want you to convert to index form, there is a quick way which I call it the push-up method. Okay, so what happens is this. Keep this number and then push this upward so that you get 8 equals to 2 cubes. Can you see? You bring the 2 here and push the cube upwards. So this is the index form. Can you see it's valid? Okay, it's valid. Same thing here. Push this up to be 3 square. And then it's equals to 9. Can you see it's valid? Yes. Yes. Okay. So same thing here. 5, you push this up. Okay, it's equal to the 1 you see here. Okay, 2, you push this up. 2 to the power of 4 is 16. Okay, so this is the index form, a very quick one. This one I think there's an error. 3 to the power of 5 is not 243, right? 3 to the power of 5 is, oh, it is 243. So it's correct, so it's correct. 3 to the power of 5 is 243. So this one is correct. Okay, then this one, 2 to the power of half. It is square root 2. So this one is also valid. This one is just showing you how to change to index form very quickly. Okay, how to change to log form?
Log 4.
So remember, you log base 4. Then the 16 is here. And then the square is here. So that when you push up, you get this. So you do the same thing. Log base 2, 32. Then this is 5. Okay. Log base 10, 3. So remember this thing, push up must give you this. Okay. So you just keep repeating the same thing for all the steps. Then you should be able to get the same thing. So I leave this exercise for you to do. But how to solve this very quickly? How do I solve for x here? Push this up. So 3 to the power of 4 is x. So the answer is just 81. Okay, same thing here. Push this up. X is 7 to the power of minus 1. So it's 17. Okay, half. Push it up. X is half square. So it's 1/4. So it's very quick solving if you can see this conversion very quickly. Can? So that is the first rule that you need to take note of. Yeah.
Over here we bring the base
Mm.
or bring the power over, but then in the questions, when we bring the base down, it's like here
Yeah, you bring it down. Originally it was here. So you bring it down. This one is the solving part. So same thing, you see, this one. Okay, if I take this, I will log log 3. X, and then I log 3, 3, 4. Then I bring the 4 in front, like a T. Yeah. Yes, that one is solving. Okay. Okay, next one. Okay, next few laws. Let me just very quickly. All these are the same. I'm not going to go through in details. Shh. Okay, take note. I just go through one here, for example. This one. Same thing, push up. So 64 is 2x minus 1 cube. So to solve for it, I cube root. So cube root is 4. So x is just 2.5. Once you solve, always sub in to just check whether your equation is valid or not. Sometimes you need to reject. Okay, sometimes you don't need to. Then you keep the solution. Okay, so now what I want to say is this. Just now I told you all, right? Yes. 10. This one. Okay, base, push it up. So 3x minus 5 is 2 to the power of 4, which is 16. So you solve it. This is 21, so x is 7. Then you sub in and check. Is both valid. Question 10, right? Yeah. 7. Yeah, it's both valid. Yeah. You push this up to become power. So 2 become the base and then this becomes the power. Then you keep the original form there. Okay, so just now we mentioned this is property number 1. Whatever base you have, this number must be the same in order for it to be 1. So I can say this is log 33 is 1. Log 67 is 1, 2. So as long as the base and the number you apply it to is the same, it ends up being 1. But when it is 1, no matter what base you have, it becomes 0. So these two properties, please remember, when you simplify, you need to use it. Okay? So these two are the properties of log. Make sure you remember them. Okay, so let's just simplify the expression here. What is log 66? 1. What is log 33? 1. So in the bracket, I'm left with log base 5. 2 times 1 minus 1. So 1. What is the answer? 0. That's all. Okay? Same thing. This is 1. This is also 1. So 9 minus 2 is 7. So log base 7 is 1. So you just need to be familiar with the laws, then you can use them. Okay, then another way to represent the same thing. This is called the natural logarithm. This is the common logarithm. Natural because it follows the natural rules of the law in the real world. Law of nature. So that's why E tells us the nature's growth rate, like population decay, population growth, okay, your radioactive decay, all those nature stuff grows in the rate of exponential growth. It will all converge to E in infinity time. Okay, so what happens is this, they try to correlate these two. So actually they say, oh, log base can be any number, right? But if this is base E, why not we change it to ln? That means we represent it using ln instead of writing log base E. Because mathematicians are lazy. They don't like to write a lot of letters. So they say, ln easier lah. Ln just means log base E. Okay, so they program it into the calculator. So you don't have to always key in log base E. Okay, what if the base is 10? Then they say, oh, then we just write LG lah. Don't need to write log base 10. Just write LG. It means log base 10. So, this is your natural log. This is your common log. Why they need to apply to common log? Because when you see the log in your calculator, this is base 10, default. you cannot key in base 5, base 3, base any number. The LOG you see here in your calculator is log base 10, default. Okay, so you need to change it to log base 10 in order to press the calculator and find the value. Okay, so log base 10 is LG, log base E is ln. So ln is also in your calculator. So this one is base 10. When they put LG, life is good, right? So this is log base 10. You push up, x is 10 cubed. So 1000. So although they didn't put the base there, you must know it's 10 lah. Same thing here. Okay, if you want to this one just want you to convert to index form, never ask you to solve. So this is log base E. This is log base E. So when you want to change it to index form, you push this up. So it's e to the power of 2x minus 1 equals to k. So this is the index form.
Isn't it 2x minus 1 to the power of 3?
No, it's always this one is the base, this one is the power. We push this up. Okay? Then this one, base 10, right? So push it up, is 10 to the power of y is equal to this thing. They never ask you to solve, they only want you to change to index form. So this one is base e. So push it up, e to the power of minus 1 is 9 minus x. So get used to this pushing up method so that you can change it to index form easily. Can? So nothing very different here.
For example, right, if they write on, can we write as log?
Base e can. Okay? Can Quick ones. This one is just changing the form. Your real deal is solving. Changing the form is just a skill you need to have.
Thank you for the good news.
Yeah. So I move on. Why my pencil?
You try to tap the top.
Tap.
Tap the top.
Then it will work.
Normally.
Okay, can. Yes.
Aren't we supposed to put the
E
E on top?
on top of what? Oh no, we push this up. This one become the power. E push this up, so this one become power. This is always the base. Then this one become the power. Which one? Okay. This. Okay. So for okay. So the changing one I leave to you. What I want you to do is the solving one. Okay. I'm going to run through a bit of the PMP here because this is not your homework. This is I never assigned this as your homework. So maybe you just it's just the first one and the last one. Hey, why my pencil? That is it. Why I cannot write? Yes. Can. Let's try to solve very quickly. First one, push up. So 3 to the power of x. 3 to the power of x is 81. Okay, so how do I, this one actually, so this is 3 to the power of 4, is it? 4. So therefore x is 4. Okay, this one, you push it up, x cubed is 5. So x is just cube root of 5. Okay, that's all. This one, x to the power of 4 is 81. So 81 is 3 to the power of 4. So therefore x must be 3. Okay, so it's all using the rules. Here, y, I push this up. So square root y, I power 4 it. It should give me 6 minus y. So square root is power half. Half times 4 is square. So y square is 6 minus y. You change it to a quadratic. So y plus 3, y minus 2. So you get 2 solutions. This one is not homework, right? This one just practice. Yeah, but I never assign as a homework, just practice. Okay, but take note, once you get the solution, always sub it back into the original equation to check if any one of it is invalid. So if my y is negative, it will make my base negative, which is invalid. So this one I need to reject. Okay, and then when y is 2, you put it back into the equation, it is still valid, it is still according to the rules. So this is the only solution I want. So logarithm need to check solution.
How can we put it back in the
As in you just put it back here and see whether it makes sense or not. Because this one will become square root minus 3, which is invalid.
oh, this cannot be square.
Yeah. So you double check whether you put it in, it makes sense or not. Okay? So, yes.
Isn't like the first rules you usually learn, isn't it like the plus the log 210 plus log 220 equals log 230?
The multiply one, huh? Okay, that one later. We haven't go there yet. That one is the more complex one. Okay, so let's look at just one more like these two. What if you have two mixed together? So you just ignore this chunk first and change the first one by doing your push-up. So 2 to the power of 1 is equal to log the entire expression you see inside. Okay, so you do one simplification first. Then let's do the second round. So let's push this out again. So this is x squared. It is equal to 3x plus 10. So once you do that, shift everything to one side and then you solve normally.
Can I look like that?
Can. So x is 5 or x is minus 2. Okay, once you solve, always plug in back to check. Because the log base x cannot be negative, this one you must reject. And then this is the answer you want. Okay, if you never reject the solution, you will lose the answer mark. So always check. Sometimes you need to reject, sometimes you don't need to. Can. Okay, so just follow through the rules. It's all about the rules, like indices like that. Can? Okay, okay, this one is the power law that I told you all just now. Remember, when you apply log, you can bring the power down as a constant in front. So this is the power rule. So far we have 3 rules. If the base and the number inside is the same, is 1. If you apply it to 1, is 0. So now is if you have a power. Doesn't matter whether these two are the same or not. Doesn't matter. You can always bring the power down as a constant to multiply in front. Okay, so this is the third rule, the power law. Okay, so when you see this, okay, don't over worry first. You go and simplify this. This is 5 cubed and 5 half. Okay, so your normal rule first. So this is 3.5. Okay, so you can always just bring the power down 3.5 and then this is log 2, 5. That's all. Cube root. Oh, that's a cube root. It's a cube root. Okay, fine. Okay, so since that is a cube root, then this is, we need to write clearly. So 5 and 5, 1/3. Okay, so this is 5 and 4 over 3. So if you simplify, you can bring the power down and then leave this as this.
Typically for multiply, is the dot in the middle or at the bottom?
Which one?
For multiply, is the dot in the middle or at the bottom?
Both doesn't matter. In the middle also can. You can write it here also can. Doesn't matter. Okay? So very, very simple rules. Later we will continue. Just remember that when there's a power, you can bring it down. Okay. Actually, right, later when I teach you the change of base law, we can press this using the calculator easily. Okay, later I will teach you that actually this one is the same as log 5 divided by log 2. So if you want to evaluate the value of log base 25, you just key into the calculator log 5 divided by log 2. This will be the numerator, this will be the denominator. Yes. To the base of, was it? Mine here is 2, yours is 5, is it? Yes. So if you want to evaluate this, right, you can just use 4 over 3 times log 5 divided by log 2. Whenever you have a different base, you can evaluate using the calculator like this. Because your calculator cannot key in base 25, right? But you can key log 5 divided by log 2. So it will give you the answer directly. Okay? So later we will come back and continue.
For this one, I can just break up to 3 to the power of 2.
So if both are 3 to the power of 2x, you can combine these two to 21.
Just 21.
21 to the power of 2x. Because you can take out the power.
But this one is 21, then I add the power.
Oh, you want to group together. Oh, then you divide this over. This one you divide this over.
Oh.
Then you subtract. Okay, see you later. Is it recess time? Oh, okay, thank you, class. Okay, go and eat. Okay. Different. So this one, right? Can. Where is the what for? The big 2. Log 2 becomes 1. Remember we had the property log base A is 1. Why is there another 2? The base is 2 what? Then this is the number I apply to the base. So it's the same one. Okay, now look at log base A8. So I change this to log base 2. Log base A2. And this is cube. Okay, log base A4. This is 2 square. So power rule says I can bring this down as a multiplier. Bring this down as a multiplier. So what I have is log base A2 here. Also a log base A2 here. So since these two are same, I can just cross it out. So my final answer is just 1.5. Okay? So remember, you are not allowed to cancel this and say must be 2 lah. No, they are different. Okay, so you need to change them to exactly of the same base. So if they're exactly the same, then you can cancel. But log base A8 and log base A4, I cannot cancel. What happened? Juggling, is it? Okay. So this is simplifying the power rule. So you can always take the power down and bring it down in front as a multiplier, a constant to multiply. Okay, so that's rule number 3. Okay, rule number 3.
Wait, this one, can you go for 1B?
1b. Okay, 1b, there's nothing much I can simplify too much. This is 2 square x plus 1. So indices law will just need you to subtract the power. Okay, so if you simplify, that's all. I can't do much to it. So this is the simplified form. Okay, I can't change much. I cannot solve. This one is just a simplified problem. Okay, so you're just applying the rules. So far we only have 3 rules. If it's the same base and the number is 1. If it's applied to 1, is 0. And then the third one is if you have a power, you can bring it down to multiply. Okay, so these are the 3 rules that we have learned. For B, do we need to bring the what? If you want, you can. But if you don't want, you can leave it like that. Yeah. Yes. Decimal or fraction, yes, can.
Teacher, have we covered how to change bases?
I haven't. Change base is next. Okay, so now, if you see this last part, these are the last 4 rules. Okay, one is if you have a product that you apply to, when you split it up, you can split it into 2 separate log functions with an addition. This is opposite of indices, so you need to be careful. Indices is like that. When it's multiply, you add the power. Okay, it's reverse. But logarithm, if the number you have is a multiple, when you split it up, it becomes a plus. So don't mix these 2 up. You all tend to always mix these 2 up. Same thing, if you have an expression here that is division, when you split it into 2 separate terms, it's a minus. So this one is product law, this is quotient law. Okay, so just take note of the difference. And then change of base, just now I told you, right? If you want to evaluate this on the calculator, it's the same as log 5 divided by log 2. You can press this on the calculator. But actually what I'm doing is I'm changing both to log base 10, 5. Log base 10, 2. So this is following this formula. So that means no matter what number I give you, let's say I give you log base 3, 7. And I want you to change this to a log base 5. So it will be log base 5, 7. And then log base 5, 3. So the 2 numbers, this will stay as the numerator. The original base will go as the denominator. And these 2 will be your new base. Yes? No, I mean for example. Okay, if you want to change to a different number. But of course, we always want to change it to a number that we can eliminate. So let's say base 7. Then I can remove this. Okay? So then they say actually there's a shortcut. Actually there's a shortcut. If I swap the order of these 2, I could use this. Because why? Log base AB, right? If I change it to log base BB, the bottom will be log base BA. Can you see? What I'm doing is the same thing as what I've done here. I keep the numerator here, the base as the denominator. This is my new base. Can you see that log BB is 1? So this is actually from the change of base law. It's not a new property. So this is an extension from here. So you can see that if I'm interested in swapping these 2, I just make it into its reciprocal. This is a shortcut. But actually you don't even need this. This is an extension. That's all. Shortcut. So all together, including the 3 I showed you just now. So this is the 4th, this is the 5th, this is the 6th. So all together 6 rules. Okay, that you need to remember. That's all. So logarithm only these 6 rules, and then all the different type of questions they can test you. Can So I will teach you how to apply. Let's look at when we reverse it, it becomes a reciprocal. So we are using an example here, like this one. When it's minus, what can I do to the two number? Yes, I combine them and then I divide the two numbers. So it's log 3. So what is this equal to? 1, that's all. So when it's plus here, what should I do to the two number inside? I times, right? But before that, you must always ensure that there is no number in front of the log expression. So this number, you need to put it back up as a power. So put it back up first. So actually it's a log base 2 4 square. Right? So before you can combine them, please make sure there's no number in front. Okay, so now since this is a plus, when I combine them, I multiply them together. Okay, so these two, I combine them by multiplying. So you will end up getting what? What is that two number?
300. No.
512. So it's 2 to the power of 9, is it? Yeah. So this is log 2. This is 512. 512 is 2 to the power of 9. So in order to simplify, I bring this down now. Right, I put it in front. Log 2 is just 1. So my final answer is just 9. Okay, so it's all about playing with the rules. So like this one. Okay, like very scary like that. But don't worry, all the base are the same. When the base are the same, all you need to take note of is this is plus, this is minus. You can combine all of them together. So when it's plus, what do you do to these two? You times, right? So these two, I times 6 times 0.5. When it's minus, what do I do? Divide. So this thing divide by 3. So 6 times 0.5 divided by 3 is 1. So log 1 is 0. That's all. So just follow the rules dutifully. Then it is just you solving the problem. Okay? Okay, take note. This one and this one is not the same. It looks like it's the same, but actually they are not. This square is for the entire expression. The entire expression. Okay, but this square only belongs to the 8. So take note of the difference. Okay, so what I can do is I can simplify this thing. What is 8? 2 cube, right? So I change this to 2 cube. Okay. Then this one, same thing. I also change this to 2 cube. So what happens next is this one. This expression here is actually 2 to the power of 6. So I'm going to rewrite this. Oops. Log 2 to the power of 6. Okay, and then this one is can. Okay, so this one, what I can do is I would like to bring the 3 in front first, so that I have 3 log base 2. And then the whole thing, there's a square there. Okay, can you see that? So this one, what I did is I simplify this to be 2 to the power of 6 first. This one, what I did is I bring my 3 down in front. Okay, so I bring my 3 down in front. So this one is just a 1, so no problem. This is just a 3 square. Okay, this one, I will bring my 6 down first, so that I get log 2 on its own. So this is just 1. So 6 plus 9, 15. Okay, so if you apply the rules properly and carefully, this is what you have. Can? Okay, yeah, can. Okay, this question next. What I will do is I will put the log together. So I take out the minus first. Become like that, right? So when it's plus, what do I do to the two numbers inside? Multiply, right? So become log 10. What is log 10? Log, as in LG, is log base 10, right? So 10 makes a 1. So this one is 1. So it's just 1. Okay? So I hope you can see that actually if you can see the rules, then actually it's all like asking you to play a game like that. Is it like a game? Like very fun, right? You just keep playing with the rules.
Very complicated game.
Very complicated game. Okay, this one? What do you think they are asking you to do? Multiply, right? Since the base is the same, since this is plus, then they are asking me to combine the two numbers you see inside. So you will end up having log base 3 x to the power of 7. So if you want, it's just 7 log 3x. That's all. Simplify only. They never say solve or anything. Okay, single log function. So this is a single log function. Yes. Because 5 times 2. When you combine them, you multiply the two numbers together. Then remember, LG is the same as log base 10. So when I say it's LG 10, it's log base 10, 10. So that's why it ends up being 1. Okay? So can you more or less know how the rule works? The simplifying one is something that O-level rarely tests. They like to test solving. Okay? So this one I won't spend too much time. You can watch the video and slowly study how to simplify these. Okay, this rule we have done before. Okay, let me... Okay, I just show you one example maybe. Question 5, which one you want me to go through? D. Okay, so let's say this one. Okay, this one. I would like to put the log expression all on one side first. So part D, what I will do is I keep the 3 here. Log base 2x minus 2y minus log base 2x plus y. So if it's minus, if they have the same base, what should I do to the two numbers inside? Divide, right? So I keep this and then I divide the two expression inside. Okay, so how do I get rid of log? I want to change it to index form. Remember what do we do? Push. So push this up so that it becomes 2 cubed. Okay, and then the log disappears already. Okay, so the rest is just you manipulating and eventually making y the subject of formula. Can you cross multiply? 8x plus 8y is x minus 2y. So 10y is minus 7x. So y is minus 7 over 10x. Just something like this. Okay, but the crucial step is this one, combining into this. And then finally pushing it up. So all your method marks are here. Combine, change to index form, and then finally here. C, can. So this one, same thing. What I will do is I will put all the log together first. Okay, so I'll put all the log together. So let's say, I squeeze here. 2 log 3y minus 3 log 3x plus 2. Then I put the 4 on the other side. Okay, before you can combine them, remember there should be no numbers in front of the log function. If not, you cannot combine them. So I will bring this up as a square. So become log 3y squared. Okay, this one I will bring this up as a cube. So become log base 3x plus 2 cube. So now I'm free to combine them. Can, but that means cannot see the other side. Huh? Okay, so how should I combine these two? If it's a subtraction. divide the expression. So I divide the y square with the x plus 2 cube. Okay? Then it's 4. So how to get rid of the log? Push. So push this upward. So this is 3 to the power of 4. Then the log disappears. The rest is just algebra. Okay? So y square will be 3 to the power of 4 is what? 81. Huh? Okay, 81 x plus 2 cube. So to find y, you just plus minus square root the whole thing. Okay? So you have two answers. Plus minus 9. And then is x plus 2, 3 over 2. Two possible answers. Can you reject? Wait, why? Because x can take any value. So in this case, no need reject. Yeah. Okay? So this is simplifying the expression, but it's from the 6 laws that you have learned. Cannot be anything out of those. So if this cannot work, try the other one. Okay, it's usually either one. Okay, so that's 5. 6 need or not? Do you all need 6? 6B. Okay, I shift. Not yet. Tomorrow, you all do a timetable one. So secretive. Which one? This one? Okay. Okay, I'm showing 6. So just now, Ravan, you say which one? 6B. Okay, this one. First thing first, I only know the value of log base A2. So I need to create a log base A2. So what I have is, sorry? Which one? A become 2 cube. 8 become 2 cube. Okay, but before that, probably you might want to split this into 2 first. Correct? Because if it's a multiply here, I can split them into 2 separate expressions. Okay, and then at the bottom, I can just plug in already. This one I know the value. This one is 0.477. Okay, so I just plug in. Okay, but this one is 1. So I can just change this to 1. Okay, the only thing is change this to 2 cube. Like what you all say. So when this is 2 cube, I can choose not to write the cube there, but bring it down here as a cube. Okay? So eventually, I just have to evaluate this value. So this is 3 times of 0.301 plus 1, then 0.477. Okay, just press the whole thing on the calculator, then that's how you get the answer. So it's not so much of the value of the answer, but it's more of the method that you use to do the question. Okay, you should like ln. You should like ln and log. Okay, I don't have a very nice answer though. 1.99. Yeah. Okay, or if you give me decimal, is like that. Fraction is like that. Okay? Yeah. The value of log base A8. This one?
No, the one below.
The one I?
Below.
This one?
Below. Above.
This one?
Yeah, you need to show the value.
You just have to show me the substitution can already. Yeah. Okay. So this is simplifying, still simplifying. Okay, what I want you to see is, wait, let me see if there's any complicated one. Okay, I never really asked you to solve this, but this one is not your homework. This is not the homework, remember? The homework is behind. So, okay, I want to go into this part, the solving one. I have what? 2 minutes. Okay, this one quick. So when you are asked to solve, they say that just like you remember when we have ax equals to ay, then the 2 power must be the same. Right? So if we have 2 log expression being the same, the number inside must be equal. It's the same application. So if I have these 2 being the same, I can straight away conclude that 2x plus 1 must be equal to 5. So x is just 2. Okay, then you double check if you plug it in, does it make sense or not, then done. Okay, so in order for you to compare the left with the right, you need to combine this into one. So the idea is both must only have 1 log expression before you can compare. So this one I combine first. This one become what? This one become what? Plus. Times the 2 expression together. So inside become like that. Then the other side, you have a log base 2, 2x minus 6. So since these 2 are both log base 2 expression, I can conclude that these 2 must be equal. So you just drop the log base, and then in the next step is a quadratic to solve. So I leave you to solve this. Yes. This one is like a solving method. Not exactly a law, but you can take it to be the 7th. Okay, the 7th law. Yes. No need, you can straight away from this step write this. Okay? So the solving part, I don't think it's a problem for you. But the idea is to make sure that both of them look the same. Okay, this one, the interesting thing is this one. Can you see these 2? It's a bit interesting. So what should you do? Swap, right? So remember, if you want to swap the order of these 2, you can change this. Ayo, time's up. You can change this into this. Okay? Change this into this. Then, actually, it works like your normal algebra question. You can let this expression be A. So let this be A. Okay? So when you let this be A, and then you simplify the expression, it becomes a quadratic. And then when you solve it, these are the 2 solutions. So A is 4. Can. So it will work like your normal substitution question. I replace this whole thing by A first. When you start seeing one of it in the denominator. So substitution will help. Sorry? Remember just now we had so just very quickly after you are done with this, don't stop here. Put back the log base 5x. Okay, so you push up. So x is 5 to the power of 4. X is 5 to the power of minus 1. So if you have these 2, right? Which one should you swap? We always like the x to be on the outside. The base to be a number. So that when you solve, you push up. You can straight away solve for x. So don't go and reciprocate this one. Go and change this instead. We like the base to be a number more than an unknown x. Okay, so remember this one. Okay, that's it. So when you go back home, catch up on the video watching, catch up on the work, so that we are at the... So with that, I know that x is 16 plus y. Okay, let me call this the real equation 1. 2 to the power of 4 is 16, right?
4 times It's 16 square.
Correct, right? 2 cube is 8 ma, then times another 216, correct? Okay. Then next one, this one, I will combine these two into one. Yes.
So when we push it, we have to do the log and log.
Yes. Okay. Then from the second equation that is given, I will combine the first one. Since the base is the same and it's subtraction, then I divide the expression first. So 4x over 8y plus 5. Okay. Then it's equal to 1. So to get rid of the log, I change to index form. So push this upward. So 8 to the power 1.
Teacher,
Yes.
can you explain how come instead of doing your method, can we just log both sides?
You can log both sides. But if you cannot log both sides, you can change 4 to a log base 2. Then you bring up. So if you don't like to do this method, changing to index form, what you can do is make 4 into a log expression. Also can. So that means I change this to log 2 with a 4 on top. Okay, which is log base 2 16. So if you want to do comparison like that also can. Then in the end you will also get this equal to 16.
By comparing,
Can. So this is alternative.
just so much easier.
I actually like the push one easier one. Okay, but you choose what is better for you. Okay, so once you are done with this, let's simplify the expression. So 4x is 64y plus 40. So let's call this equation 2. Then the rest is just solving simultaneous equation. So that one I'm not showing.
Really like done with log.
Almost. Then we will do exponential, then we are done. Okay?
So can I just do the...
Can.
Can we divide by 4?
Can we divide by 4 first? Can. If you want to make it simpler. So that means start from here. Okay, then using these two equations, okay, you can proceed with solving already. Okay, so I leave you to do the solving. I don't think solving I need to show you. I just want to show you how to get the equation.
So it's just push, like make it both, like make sure it's all long, then push the base to the other side.
Yes.
Then
Then can form simultaneous
when
already.
you push the base to the other side, you get rid of the
Log. Yes. Okay? Yes. This one? You want this part? Okay. Okay, so simultaneous also don't need to be scared.
Teacher, can I hand in the work side?
Oh, and then we just
Can.
take something.
The question, like 15 question, I just give you one, and then the other paper.
Can. Okay, so after 14, let's look at part B, 14B. So if you want to form simultaneous equation for this is just normal indices. So 2 to the power of x. This is 2 to the power of 2 with the 7y. And this is 2 cube. So indices says that if it's division, you can subtract the power. So minus 14y. Okay, knowing that both sides has the same base, you can drop the base and just compare the power. So this is your first equation. Okay, equation 1. Okay, equation 2, you want to be able to combine the log base 3 expression on the left. What do you get? So log base 3, if it's minus, what do you do to the expression? Divide. So it's a x over 5 inside. Same thing here, but the difference is this is a plus. So what do you do? Multiply. So multiply the expression inside. So now that both sides are a single log function, same base number, you can drop and compare the expression inside.
Oh, so just cancel out.
Yes. So you just have to show me the comparison. So using these two equations, then you are free to solve. So let's call this equation 2. So sub 1 into the other one and solve. So solving, I leave it to you.
Is this 7.1 or 7?
What happened to the log?
Disappear. Because since both are log base 3, the expression inside must be the same.
Because both sides have log 3.
Correct. So it works just like indices. When the base is the same, the power must be equal. When the log base 3 is the same, the expression inside must be the same. Yes.
During the exam, can we just plug in simultaneous into the calculator, or must we show our working?
Show working. Yeah. Which one? Ln and log is the same thing. Ln is log base e. Yeah, so it's just another way of writing. Just that it's a natural log. Okay, wait, I don't want to drag the question. Okay, part C. Okay, part C, I just copy the question so I don't have to go over. Okay, ln 3x minus y is 2 ln 6 minus ln 9. First equation. So when you see ln, it works like log. Don't have to worry about it. So this one is done. I don't need to do anything. What I need to do is to combine this one into a single ln function. Before I can combine, I cannot have any number before the ln or log expression. So this one must move up. When you move up, it becomes a power. So this is a ln 6 square, so it's a ln 36. Okay?
This is ln 6 divided. This is ln e 6 over 9.
No need the e. So between these two, when it's a subtraction, what do I do to the number inside? Divide. So 36 divided by 9 is 4. Okay? So this one can. Then now I put the other ln expression beside it. Since both are ln, I can combine these to compare. So this is my first equation. So I can make this into a y expression. Okay, let's call this equation 1. So part C, first equation, you get this out of the expression. Okay, second one, they gave me this. Okay, this is what they give me. So same thing, I will apply indices law. This thing is a 2x. Okay, when it's over, it's divide. It's the same thing. If there's no power there, means it's a 1. So what can I do to this?
Minus.
Subtract the power. So 2x minus y. This is e to the power of 1. So since both are base e, I can compare the power. So my equation is this one. So this is my equation 2. Then I leave you to solve the simultaneous equation. Okay, so the difficulty is just getting that 2 equation out. The rest is normal simultaneous equation solving. Yes.
Or because for log, right,
Mm.
there's a number in front.
Yeah.
Let's say the log has the same base. Then for the 2, right, I use the log same base, then 2.
So
Like for 2, 106.
this one,
Like let's say you're log 6.
log. Big 6.
Then 2, 2, 2, right?
2, 2. You write out an expression, then you show me. Okay, so this one is forming simultaneous equation. Then what if you are given an expression for you to solve? So this is the other one. And then you bring down the 2, actually it's 2 times 1. Yeah. Yes. Okay, so when you are given expression like that, you can solve straight away. Okay, you can solve straight away. So what you do is you want in your power there is a x that you want to solve. So you need to bring down the power. The function that allows you to bring down the power is either log both sides or ln both sides. So there's two ways you can address this. If I ln both sides, I will get this. But I can also choose to log both sides. It will give me the same answer, so no concern about that. It's just personal preference. You like to write log or ln. Okay, it's just personal preference. Okay, so once you apply this, you can use the power rule to bring this down. Okay, the whole idea is to be able to bring the power down so that you can solve the unknown. So now I can bring my x plus 2 down. So I'm showing you both, but either one will do. You don't need to show both. You just need either one of them. Okay, so this one will be log 5, then log 18. So remember log 5, ln 5, they are just a number on the calculator. It's just a value. Okay, so you can just treat it as a value to divide over. Okay, it's just a value. So x is just this whole thing minus the 2. Then you give me your answer in 3SF. Okay, same thing here. The log 5 is just a number. So to solve for x, this entire answer, just subtract 2. Give me 3SF. Okay, so either one will give you the same answer. Just give me the 3SF answer. Whether you like ln or log, up to you. Nobody will dictate that. Minus 2. Okay? Okay, 204. Okay, 3SF. Okay, so B, in order for you to be able to simplify, you need to make sure you can combine them first. So let me show you B over here. So B is 7x. And then a dot there means times. It's another way of writing multiply in a lazy way. Okay, 1.5. So I want to combine this into 1. I need to make this base 7. Yes.
But we put backwards for 15A.
15A?
You know push up, right?
Yeah.
So what, just reverse it?
Can. Also can. You can change it to log form. Okay, so here, multiply means you add the power. So x plus 2x is 3x. And then plus 4. Okay, so you add up the powers. So this is x plus 4 plus 2x. This one. Okay, I'm just skipping some steps here. Okay, equal to 1.5. Then now we are back to part A. You can log or ln both sides. Your choice. Yes. Someone will raise your hand. Okay, so ln both sides. My 3x plus 4 can bring down. So 3x plus 4 I bring down. The ln 7 I divide over. So to solve for x, I just subtract this whole thing by 4 and then divide by 3. Okay? Okay? So what if your expression got exponential in it? Okay, then you will be strongly recommended to use ln. Okay, because it's log base E. But even if you use log, it will still be correct. Okay, but I'm just saying that it's more convenient to use log. So let me just show you C and D. Okay, I write C here. E for X is 9. So if I take ln, right? If I take ln, it's very neat because it means I can bring this down.
Wouldn't that just be 1?
And ln E is log base E. So actually it becomes 1. It's gone. Okay, the ln E here is actually 1. So it's gone. So straight away, X will be ln 9 divided by 4. Okay, so you can just give me the answer direct. But if you insist, I want to use log, I don't like ln, you can also do log. Okay, just that your log 9, you must divide by log E, right? And then the whole thing divide by 4. So you can still do that. It's still feasible. Just that working wise is neater when you use ln because the ln E sort of cancels out. Okay, so either case will work. You just have to see which one you like. Yeah. You learn a log function, but it's a number to begin with, so no difference.
Oh, yeah.
Okay, last one, part D here. E to the power of 2x plus 1 is log 6. This log 6 is just a number, so you don't have to worry about it. It's just a constant number that you have there. So if you learn both sides, even if you see ln log, it looks so scary, right? But it's just a number that you key in. It's just like your 7. Okay, so bring down this power, and then the ln E disappears. So all you have to do is to subtract 1, and then the whole thing divide by 2.
So it's just log 6.
Yes, so when you press the calculator, it's just a value. So don't need to be so scared of the expression you see there. So it's a minus 0.625. Okay? So exponential is like this. Okay, nothing very scary. Okay, the very last part is all the substitution that you will see. Okay, all the substitution expression. So this part I need to explain. Okay, the whole 16, 17, 18 I will go through because it's a type of question that O-level likes to test. Okay, let me put it somewhere where there's space. Okay, here. Oops. Okay, this one. Let's look at 16. Okay, question 16. This is the expression, and the ultimate goal is to find the value of 6 to the power of x. So when you see this, you need to do some form of splitting. Okay, so this is the rule that is important here. So A, B, N, I think we learned this in indices. It's AN, BN. Both of them will get the same power. When it's division, they will also get the same power. But now we are looking at the reverse direction. If each of them have the same power, you can combine the base by multiplying them. So we do reverse. So now I need to make these two of the same power. So before I can do that, I split this into 2. So this is 3 to the power of x times 3 cubed. Okay, then I'm going to split this into 2 also. 2 to the power of x times 2 to the power minus 5. So the rest. Okay, so what I'm doing here is when I have AM times AN, I add the power, right? But now is if I have this, I split them into its individual parts. So what I'm doing in the splitting is looking at the reverse. We are so used in E-math to combine. But A-math wants you to do the opposite. That means if I give you this, I want you to split them into its individual parts. So if you have x plus 3, I split them back into its original 2. Same thing here, I split them back into its original 2 before I combine them. So what's the purpose of that is because if I combine these two together, what will I get? Yes, can you see that if I have two numbers with the same power, I can multiply that two base together. So this is the same as 3 times 2 with the power x. Can you see that? So I want to combine these two. Then the rest is just a number. This one no problem. This is 27. Okay, this one is 1 over 32, is it? This one is 1 over 32. This one is this. Okay, so I just rearrange them to the order I want. So this is the 6 to the power of x that I want to find the value. So this is what I want. The rest are just numbers that I want to solve. So 15, I divide by the 27. I divide by the 1 over 32. Bring these two over to divide. So 15 divided by the 27, divide by the 1 over 32. I end up having 160 over 9. So that's it. That's the value I want. Oh, they say 3SF, is it? Oh no, they haven't. They say find the value of this first, hence solve for x. Okay, so using this, how to solve for x? Ln both sides or log both sides. So if you log both sides, so x is just this whole thing, divide by log 6. They say 3SF. 61. Okay, 3SF. Okay, so the splitting will help when we are doing A-math indices. Okay, the splitting is the key step. Okay, I show you one more. Okay, so now they want me to somehow combine the power x together. So first thing first, I change this back to 4 to the power of x. Okay, why I do that is so that they share the same power. So when these two share the same power, I can take out the power and multiply the number inside. Okay, it will be the same. So I put them together. So this is 12 to the power of x. Then what else can I do? How do I group all the power x together? Divide over, right? So I divide this over. Can you see this rule that we applied before? If they are separate, I could actually combine them into one and write this as this instead. Okay, so once you combine them already, solving is very easy. You just log both sides. Okay, when you log both sides, you can bring down the power already. Okay, so it's all about following the rules. Okay? This one? No more already. This one last one.
How many marks is it?
This kind? Combine, divide, learn, answer 4 marks. Yeah.
Parts are the marks awarded.
First one is where you can combine them. So either here or here. Okay, then when you take log, okay, and then you simply, no, not take log. You combine, okay, no. This one is also 1 mark. Okay, then when you take log and then you solve 4 marks. Okay, so the very last type that you will see is question 18, which is solving by substitution. So the substitution, let me just show you how it can be done. They will always say suitable substitution. So you look carefully. There will be a quadratic that you can form. So if you let this be A. So actually this is A squared. Can you see that? Because E2x is the same as EX with a square. So actually this expression I can convert it to A squared 3A plus 4. So if you try to form the quadratic, this is the quadratic you will get, and then these are the 2 solutions you will have.
Wait, Miss Ron, can you explain that again?
I substitute A to be e to the power of x. So when you see e to the power of x, you change it to A.
It becomes A squared.
Correct. So once you see that, your quadratic comes out, you solve. So after you solve, don't stop there. You put back your e to the power of x. Okay? So this one, you ln both sides. Then x is just ln 4. This one, no solution because exponential is always positive. Okay? So I'm just showing you how to plug in. This one look at it. What do you think you should sub in your AS? This one, right? The whole thing, I let it be A. So you will end up having the quadratic A minus 6 over A equals to 2. So if you multiply throughout by A, you will also get your A squared minus 6 minus 2A. Then you solve. Okay, so I only want to show you how to do the substitution. What about part C? What should I let my e to the power of x? Then this one will be A, this one will be square root A leh. I don't like square root A for quadratic.
Turn it into the power.
So maybe we let this be A. Okay, we let this be A. So this, isn't this the same as this square? So this thing is the equivalent of this. So actually this is A squared. Okay, can you see this is A squared? So 2A plus 35. So from there, go and solve the quadratic. So no matter what expression they gave you, you must be able to do a substitution that eventually leads you to a quadratic. Then solve, then plug back. Okay, so no matter what kind of expression you see here, there must be a way that you can do substitution so that you get the quadratic and then you solve. Okay, so this one, nothing too fancy about it. Yes.
The square root over there, isn't it like you're supposed to sub A as e to the power of x?
Square root. So the square root of this thing is this. I let this be A. So this is the same as this thing squared. Correct? The square root disappear, become this. So actually this is A squared. Yeah, so I let this be A. Yes.
How does the negative 6e minus 2x becomes negative 6 over 2?
This one? This is the same as this.
Okay.
Yeah, so I replaced that with A. Yeah, negative power when you bring down become positive. Okay? Seeing some heads down already. 2 board. All finished already. Yes. 6. But you use log this divided by log 6, is it? To get the value?
Yeah.
Then okay. Or you use the... But you must know it's log this value divided by log 6.
So it's okay for that.
Yeah.
But I need to know.
Correct. 16 here. Can see or not? Too small, huh? Okay, next is the graph. I've told you all about the graph before. This one. Can see or not? Messy. Okay, the homework is the PMP on this page, page 18. Oh no, 17. Yes. Okay. I think we should be able to finish today. Good job. Actually, I have a quiz, but never mind. I don't think can squeeze today. Yeah. 3 to the power of 4x plus 4. Square. Okay, 2. To half, yes. And this is 3 to the power of 4x. Yeah, okay, I see. The half cancels out, right? So become 2x plus 1. Then you go and plus the 4x. So 6x plus 1 more. Then what do you want to find? Oh, you want to split now. I see. So this one cancel out is 3. 2x plus 1 plus the 4x. So it's 6x plus 1. So if I split, it will be this. So this one 3x. You put in the something to substitute. This one is y. Y 6. And then got the 3. That's the answer. Correct. The 3, right? This one is y. Y to the power 6.
This one you add.
Yeah, here. Okay. Next part is the graph. So graph I mentioned to you all before, right? Okay, listen. This is your log function. The only thing that determines the shape is the value of A. If it's greater than 1, it looks like this. So actually, this one greater than 1. This graph is, okay, I just write graph A. This one is graph A. So this is graph A. This is greater than 1. Graph A. Yes, can. This is greater than 1 because this is the same as log base 10. So this is graph A. This is the same as log base E. So also greater than 1. So all these 4 graphs on the left follows this. No matter how I change the base number, as long as it's greater than 1, this is the shape. And it always passes through 1 at the x-axis. Because anything that you subtract to the value 1 gives you 0. Remember, you ln 1 is 0. You log 1 is also 0. So anything that you place it to be 1 gives you 0. So that's why it cuts here. So these 4 graphs looks like this. No matter how you draw, is this. Okay, but however, if you change the base to be a value between 0 and 1, then the shape becomes like this. So this is graph B. So these two will look graph B. So in past history of 10 years, they have never asked you to plot a ln or log graph lah. Okay, but who knows? Okay, who knows? So you need to know the shape. Oh, that one I'm not setting end of year what? Anything is possible. I don't know. The paper is not out. It's not even created yet. Okay, anyway, so just to remind you, exponential graph, y equals to ax or y equals to ex. Okay, they all look like this. Okay, and then this thing is 1. So this is your exponential graph. And then we mentioned that if the power becomes negative, then you flip the other side. So this one is the exponential graph that you need to know. Just know the shape. If you are asked to sketch, you should also know how to sketch. Okay, but log graph, take note, log graph, we are only particular about this. Okay, we are only particular about this. So if the A is positive, then your shape is like that. Okay, and then it always passes through at 1. So if your A is between 0 and 1, then it's the other side. So just need to memorize that this is how they look like. So same thing for, okay, ln. Ln looks like this because ln is log base E. Okay, so ln graph follows this one. Okay, so these are all the graph you need to know at this section. Yes. Ln graph 2 point something is greater than 1 also mah. So when the value of A is greater than 1, this is the shape.
Wait, so this one, the one on top is
Cannot be 1.
y, when something is to the power of x, and the one on below is something like log x.
Yeah, correct. Okay, then what if I tweak the expression? I say log base A x minus 3. What should this become? Remember, log 1 gives you 0. So when will it cut the x-axis? At 0. When what is 1? I need this to be equal to 0, right? If I want it to cut the x-axis. So x must be 4. So just remember, you need this whatever expression here to be equal to 1. Then it can cut at 0. So even if I make this scary looking, it's okay. Just equate to 1 and find the x value. Then you know what it should be.
If it's not 1, then what will it be?
If it's not 1, it's a different value already.
Wait, so this
Yeah.
so that means that the line will intersect at 4.
Yes. So that means if this is the graph they ask you to sketch, then this value here must be 4. Because it's only when it's 4, it's log 1. That's why it cuts the x-axis. Yes.
My hair is dropping.
The expression inside cannot be 0. Yeah, must be always greater than positive. Okay, so that's the graph. Okay, the very last part is application. So like what I mentioned, application is just understanding the question. They will always give you an equation to use. At the start of the equation, the question, they will always give you an equation. So this is like your chemistry question, the acidity of your H plus ion, right? So you put in this into the formula, you can calculate pH. So pH,
Are we serious?
okay, then you put this into the calculator.
Was this your
Okay, you just sub in because they say this is your H plus, your acid concentration. So when you sub in this into the formula, you press calculator, it gives you a value which is 6.252. So they ask you what is the color of the flower. Yes.
So for this type of question, just subbing less.
Yes, they always give you a formula to sub in. So what is the color? Pink. Because 6.2 is here. So the color is pink lah. Yes. Log base 10, you can change to LG, is the same. Yeah. Yeah, so they won't give you that number. They will give you slightly more or slightly less. Okay, then the other one, of course, when you put in 7.8, then you go and calculate, it will give you 5.11. What color is that? Blue. So you just have to answer according to the question. That's why it's called a problem sum question. So no matter what, they always give you an equation first. Then they start asking you question. So part 1 says after 10,000 years. So they are telling you sub t as 10,000. So you go and sub in. So this kind of question is not difficult. The difficulty lies with understanding what they want you to do. So put in your 10,000. Then you press calculator. It gives you this. Okay, just now I calculate already so that it saves time. Okay, 3SF. Okay, then they say how long will it take before the radium is halved? So half means sub in what value? Not half. What is the initial amount? What is the initial amount of radium? 100, right? Is when T is 0. So actually this is your initial, your R0. So you know initial is 100. They say when it's half, that means they are asking you to sub in R as 50. So you must be able to interpret what they want. Yeah, it's not difficult. You just need to understand what they are asking you. So remember, divide the 100 over. Before you can take ln or log, you cannot have any number before the exponential expression or the number. So now you can ln both sides. Okay, you can ln both sides. So after you ln both sides, you can take the power down. I need to divide the 100 over. Okay, remember, you don't straight away ln from here. This must not have any number attached to the exponential when you ln. So get rid of the 100 first before you ln both sides. This one is a crucial step. This one is a crucial step. Okay, this one I write here somewhere. Always, the break is coming. Wait. You go, run. Always make sure there is no coefficient in front. Not no coefficient. The coefficient of E is 1. Okay, before you ln. Before taking ln on both sides. Okay, this is a crucial step. And every year I will have students taking ln before dividing. Okay, so once you do that, you can take the power down. Okay, you can go ahead and skip steps. I'm just being very explicit here. Okay, 50 over 100 is just half. I be lazy, I write half. Okay, so ln E is 1. After I take down, this is 1. So actually you don't want to write this also can. Just omit. Then to solve for T, divide the whole expression by that chunk of decimal there. Yes. No time to give, I think next lesson. See, to prove that I did is here. Quiz, log. A log quiz. I think no time. Can. So it's about 1620 years. 3SF. Okay? So I think over the years, if you are free, go and look at the 10-year series. They like to test half, double, reduce to 30% of what is left. So the only number they can play with is this number you sub in. Okay, and then the only trap you fall into is that you forget to make this, get rid of the 100 here. Okay, then you start to take ln. Then your answer will be nonsense. Okay, so this one be careful.
This one.
Yes.
50 is because the radian is half.
Yes.
But is there any questions you said like percentage?
So like reduce to 30% left. So that means 30% left means left 30 lah.
For 100.
If 100 lor. So you just follow the instruction they say. Okay? Can Okay, you look at these 3 questions. This one I think we did before, a similar one. But part 1, okay, I'm not showing how to substitute. I just tell you what is the thing we need to substitute. Beginning means what?
0.
So we sub t as 0. So this one is the first one. Part 2, population after 4 days. What do I sub? Sub t as 4. So remember the equation is here. You just sub in only. Okay, what about part 3? The n is 400. So remember when you plug in the 400, the crucial step is to get rid of that number first. Correct. So this one becomes 4. After it becomes 4, then you take ln. So this is the crucial step. I just show you the crucial part. Okay, before you take ln for... Yes. Log also can. Same answer. Okay. What about 2 part 1? Initial temperature. X is 0. Okay, sub X as 0. Then this one even easier. They straight away tell you what to substitute. So this one I leave it. Just part 3. Part 3, I want to remind you that when you sub in 30, please get rid of the 85 first. So get rid of the 85 before you start taking ln or log. So if you like log, do log. Okay, bring down the x. Okay, before you divide and solve. So this one I leave it to you. Last one. This is my equation. They say find the intensity when the thickness is 1.5. So sub what? Sub t as 1.5. Okay, part 2. I need to find the thickness if the intensity is 0.5. So sub I equals to 0.5. So 0.5. This question, there's no need to get rid of any number. You can straight away learn already. So all this you should have watched the video and do, but I'm just going through one more time in case you haven't watched.
You should like give us less homework so you more time.
Yeah.
Hello, my due date is like so long later.
When's the due date?
It's Friday.
Oh. That's not even long.
Wait, that's right.
Yeah?
How do you simplify the one
Friday. Friday, so let's say 3 days.
t ln
14 divided by 3.
When you take ln on both sides, it becomes ln 4 and then ln 1.65t. But I bring the t down.
Okay, then
Then after that you want to solve for the t, you just ln 4 divided by ln 1.65. Yes. Can. So you can go ahead and skip some steps if you can already visualize the bringing down, the solving. Don't need to show every single step that I show. Can skip, you can skip. Okay?
Manipulation.
Yes. Okay, this is the log. We learned that all the laws of indices applies. Okay, all the laws of indices that you have learned in E-math, you can apply in A. But we are using it reversely. Okay, that means for example, just now we say that when it's AM times AN, we get AM plus N. So if the question gives you 6 3x plus 1, we will like to split it into 6 3x times 6. Okay, so we are doing the reverse for A-math. Okay, same thing. We also learned that when we have AB n, each of them will get the same power. Okay, if you can still remember. So if I have 3 to the power of x times 2 to the power of x, I can combine it to be, which is 6x. So AMF likes you to do the reverse. Same thing, this one. We learned that we can split them. Both of them will get the same power in EMAF. But AMF tells you that if you have 2 expressions, you can combine them and simplify it as 3 to the power of x. Okay, so AMF likes to do the opposite direction. Okay, what else? They like you to do substitution. So 5.1 has substitution like this kind. So example, substitution. So for example, I have 9x plus 1 is 10 3x. What do you think I should let A be? So I should sub A to be 3 to the power of x. So this is my A. So I need to bring in the substitution. So to me, this is 3 square. So when I simplify, this is my 2x plus 2. And then I will need to split it into 2 parts. One is this. The other one is a 3 square. Okay, so if you see carefully, this is a 9. This is a A square. This is 9. So to form the quadratic is actually a 9a square plus 1 plus 10a. Then you go and solve accordingly. So 5.1 talks about this. Yeah, when you bring over, I haven't bring over. Okay, so the entire 5.1 talks about this. 5.2, we talk about exponential. So exponential follows the same rules. So exponential expression, okay, is where the Euler number comes in. So it follows the same rule as what you see here. So if you have e to the power of x times e to the power of 1, it is adding power. It's the same exact rule. So same rules apply. Okay, so the entire expression, if I change from numbers to exponential expression, it follows the same exact rules. So that's what they tell us. And then they tell us that the two graphs look like this. So this is y equals to ex. This is y equals to e minus x. So there's these two types of graphs. And then of course there's the application question, the problem sum. So 5.2 only like that. Okay, then we go into 5.3 and 5.4, which is the log and ln expression. So 5.3 and 5.4. Okay, there are some laws about log. So log base AB, they tell you that the b that you have there must always be positive. Okay, and then the base number you have here must be positive, and it also cannot be 1. So these are some things, some rules that restricts your log expression. And then the law says that log base AA is 1. Okay, log base A1 is 0. Okay, if you have a power, you can always bring it down as a constant to multiply. Okay, what other rules you have? If you have two expressions with the same base, you can combine them into one by multiplying the expression. If it's subtraction, then you can divide. Okay, then of course if you have two expression of the same base, you can equate these two together. That means m is equal to n. Okay, and then the very last one, I got one more. What is it? Oh, changing to index form. Okay, so let's say this is ax equals to y. Okay, for example. So I push it up, change to index form, x is a to the power of y. Okay, so these are some rules that applies. Whether it's log or ln, you just need to know that it's the same thing. Log is log base 10, LG. Log base E is ln. They are the same thing. So you can change this to ln expression, the same rules applies. So ln being log base E, so ln E is also 1. So this one I just take note. Ln 1 is also 0. Okay, all these rules about what is here applies to ln as well. So 5.3, 5.4 talks about that. 5.5 is the application. And then the last one is the log graph. So remember log base AB, if your A is positive, not just positive, greater than 1, is it? Greater than 1. Okay, it looks like that. If it's between 0 and 1, then it's the other direction. So that's it, whole chapter. Okay, this is the essence. Okay, have your snack break. Yes. This one can.